Okay, and recently people got interested in AI and then they are curious about the relationship between AI and deep learning and machine learning. So what is the relationship between all these terminologies? First of all, AI is the largest terminology, so it covers this much. And then machine learning is a subset of artificial intelligence, like this, and deep learning here. But this figure is a little misleading. Recently, this is deep learning. Okay, so when it comes to AI, then most of the algorithms are based on deep learning recently. And why deep learning? Okay, to understand the complex problems, so we said we have to increase the model complexity to achieve a more powerful expression power. And the deep learning is expressive and generalizing well. Okay, so deep learning means actually we make a neural network deep. So we stack the layers to make it deep. So it means basically the deep learning is based on more complex models. And even with these complex models, then it can generalize well. Generalize well means, okay, we train the model with training samples, but if the model is not applicable, if the model is not working well with the new data samples, then we say, oh, the generalization is not good. But deep learning has a good generalization property, which means when we train the deep neural network with the training samples, then the neural network, the deep neural network can work well with the completely new data samples. Okay, then the next one is pattern recognition. What is the relationship between the supervised learning and pattern recognition? Pattern recognition is actually a supervised learning. Okay, so the pattern recognition can be summarized with this figure. So from the real world, we measure data. So getting the data samples, and we need pre-processing. And after that, we have too many features, then we have to reduce the dimensionality. And then we train. So training process is somewhere. And after training, then we can predict. Okay. And based on the performance, then we can choose which model is better. Okay. But recently, we use deep learning. So in deep learning, this part can be implemented as just one unified model. Okay. And there are many examples of pattern recognition, including face detection, recognition, speech recognition, and beacon recognition, etc., etc. And the recommendation systems are really popular machine learning applications. Okay, so Amazon and Google and Netflix, they make a lot of money based on recommendation systems. And we have so many more applications: web search, speech, and handwriting, etc., etc. You can read by yourself. And the machine learning or AI, they are interdisciplinary area. Okay, so a long time ago in 1960s, AI is combination of neuroscience and some computer science. That was it. But recently, machine learning is combination of computer science and optimization from industrial engineering and the neuroscience and physics and statistical physics and statistics and information theory. So machine learning is completely interdisciplinary, and then math is everywhere. And machine learning is really important. And Bill Gates said a long time ago, a breakthrough in machine learning would be worth 10 Microsofts, okay, which is huge. And the machine learning is the next internet, or machine learning is the hot new thing, or machine learning is going to result in a real revolution, or Jerry Yang said machine learning is today's discontinuity. Okay. And there is a prerequisite math for machine learning. Actually, calculus is a prerequisite for any kinds of engineering class or science class. And the linear algebra. Data is given as a vector or matrix or a tensor. Okay. And simple operations can be implemented as matrix or vector. So in machine learning, pretty much everything is represented as vector or matrix. So without the linear algebra, then we cannot understand our data or our transformation functions. And we need probability and statistics because everything is probabilistic due to noise. Okay, and the single point does not say much. Think about your score in class. In class, let's say you take an exam, okay, and then you got 80. Okay, so your score is 80. Then what does that mean? You don't know the meaning of 80, right? Then usually the students ask the mean of the exam. Okay, so you have 80. Then your question is, what is the average of the exam? If the average is 70, then 80 is pretty good. But average is 90, then the 80 is not that great. So you can understand how good or how bad your score is based on the average. Okay, and the average is not enough. Let's say the average is 70 and your score is 80. And then the next question is the variance. What is the variance of this exam? If the variance is 1, then something like this. Then 80 is pretty good. You are the best of this class, I guess. But if the variance is 20, then it's something like this. Then you are, roughly speaking, you are around the average. Okay. So statistics comes to the rescue. Okay. So when you have just one number and you don't know how good or how bad the number is, then the statistics comes to rescue. Okay, that's pretty much it. And if you have any questions, comments, then you can email me.